So I was thinking that today we could try to solve the homework exercises. Pardon? All the ones that have been marked already. So actually, we've gone through one, so maybe we can go through 2 and 3. Is that okay? Shall we turn the lights? Shall we dim the lights? And then I'm going to try to cover this part, iterators and generators. And then next time we're going to do real world Python, just part 1, which will look at a little bit at Pandas, which is a library for data science. And that's pretty much going to be the entire module. All right. The homework that you got yesterday, all right, is the final homework. All right, it's going to be worth 30% of your mark. All right. So treat it seriously. I'm going to be waiting for submissions to the contest. Remember that. And you're going to have very little time to vote for it. So pretty much on Wednesday. That's your window. So try not to miss that. So remember to submit a screen capture for your contest. And if you don't want to enter the contest, it's fine. But do submit a piece of code. It's worth 10%. All right. So let's go to assignment. Assignment 2 and 3. Okay. Assignment 4 is still is due tonight. So all I can do is publish solutions. All right. So average of random, right? Notice one thing here, that no. So this one prints. We're not looking at returns yet, right? Because we didn't have enough capability to use return values. So we just want to print. And we were supposed to solve these with what we knew of that particular week, right? So let me get rid of this. AVG of, right? And I can't quite remember what we knew at that time. And no worries, we're going to have multiple solutions to that. AVG of random, we get number n. As argument, which is supposed to be the number of elements, right? So we're going to have to compute the sum of n random numbers and divide by n. So let's initialize a sum to 0. Let's use a counter. While counter is less than n. All right. sum plus equal, and I have to remember how to read a random number. And how would I do that? I'm going to import random, right? I will remember at least that there's a package called random. And then if I say dear random, right, this would show me the contents of that, right? And we have this randint, which looks like random integer, so might do what we want, right? So I'm going to try it a few times. Random dot randint, and we need 2 arguments. So this tells me that I need 2 arguments. So I'm going to say 10 and 20, just as a wild guess. And as I keep running it, I can see that our random numbers are coming. So we're going to use this, right? So I'm gonna say from random import randint, right? Did we used to have limits between 0 and 100, right? So we have limits 0 and 100. All right. So at the end, we're gonna want to print sum divided by n, right? This would be the average. So this would be a solution. Yes? A number from 1 to 10. Was that the requirement? Oh, prints them and then prints their average. All right, so let's do that. I keep. All right, so we have a counter, and the counter needs to be incremented, and then yeah, let's store here R is randint, and then we can print then counter is, and then say R, and then sum plus equals R, right? And then let's do this nicely. Okay. So now we can do Python 3 minus I documents test.py, and then we would have record as avg of random 10, and we get something like this. Okay. Now, taking advantage of what we've learned, right? We could have different solutions. Def avg of rnd, let's call it 1, and All right. So we could first of all generate a list of random numbers. So I'm going to say L is rand int 0 to 100 for I in one range 1 sorry 0 n. All right. Then I could do for k in L print. So I'm just going to copy this. And let's do it this way. For I, k in zip L print random number, and this would be I is, let's make this R. Everybody understands what's happening here? And then finally, sum L divided by N, right? What do we call this one? Average of RNB1. Right? Okay. Let's see. Are there any other solutions? No? How about, so def avg, all right, we define a helper that takes an argument I and then prints this. So we say R equals and then we do this. And then we return R. And then we say L equals okay. Everybody understand what's going on? So now I don't need a second for loop. Is okay. Well, they're all good. Right? So at this level of simplicity, it really depends which one you write faster and which one is easier to understand, right? So if this was a large program, they have different advantages, there's different trade-offs, right? So if I would do random 2, right, I would get something like this, right? The difference being now that I have 0 to 9, so perhaps it would have been good to say I plus 1 here. Okay. So in this one, right, you can say that there's a separation of concerns, right? The generation of the list and the printing of the list are separate, and they could further be put in separate helpers. If this is a large program, this is a useful thing to have, right? This one, on the other hand, is faster because I only go through the elements of a list once, right? Here, I iterate twice. I iterate once in generating the list, so I have a for loop here, and I have another for loop here. There's 2 for loops, right? So it's essentially like I go through all the elements once, and then I go back to the beginning and I go through all the elements again. All right? Here, I don't do that. I go through all the elements, I print them and generate them at the same time, or generate them and print them at the same time, right? So the last one is going to be fast, right? However, if at this point I want to say, oh, let me turn off the printing, or let me turn off the, well, I can only turn off the printing, right? It's not that the printing is a separate concern anymore. It is intermingled with the generation. So that creates coupling, what we call in software engineering coupling. Coupling is a bad thing, right? So you want to be able to remove parts of the code from the entire code base, and once that is removed, the links to that piece of code, you want them to be few. You don't want many, right? You want some sort of modularization such that at each point you can take off entire components, and as you take them off, the amount of disconnections, the number of things to be fixed, right, is relatively small, right? So this is called coupling, and is you don't want to have too much coupling. Questions here? But just be aware that these things are possible, right? There are different ways of writing code. Next question. We want to print a diamond, pattern of size n. All right. So if you look at this one, right? Assume, so I've put these spaces here just because I wanted to have some indentation, but it is okay if you print this this star if it comes in the first column of the text. That's fine, right? And adding or removing the extra spaces, it's not really a problem, right? So what do we want here? One important thing is that I don't want to print anymore. There's no spaces here, right? See, if I try to, if I go and if I try to select, I cannot select beyond the line. So some people were thinking that they have to generate some sort of a rectangle of characters, where here at the right, at the end of every string of stars, there will be more spaces, right? That doesn't need to be there. What we want is a certain number of spaces followed by a certain number of stars in such a way that their length is the length of the spaces is decreasing and the length of the stars is increasing. All right. So this is 15, and I think we have 15 lines, right? So how many spaces do we have here? Right. So if I put my cursor here, I'm going to count 1, 2, 3, 4, 5, 6, 7, which is 15 divided by 2, right? 15 divided by 2 as an integer, right? So that 7 decreases to 0, and then the number of stars is going to increase to 8 minus that number, right, times 2 plus 1. All right, so we're going to have two separate loops, one that prints the first half and another one that prints the second half. So let's do just that. So let's do diamond. All right, so we're going to have a loop that goes through the number of lines, right? And I'm just going to write a for loop because it's easier, right? Instead of a while loop that has a counter and the counter is increased. So for I in range, so we're going to go from 0 to, actually we're going to go from 1 to n divided by 2. We're going to go downwards. So n divided by 2 to 0, step minus 1. Minus 1 or minus 1 here? I think it might be minus 1. Right? So this would be the lines, right? The first half of the diamond. So now we're going to print what? Space times I plus, and probably this needs to be in a bracket, and I don't need brackets here actually, plus, so I'm going to have a star times, and here we need to have n minus n divided by 2 times this, and actually I don't need this, plus 1. All right, so let's see what we get for this. Let's see if we get the right result. Okay. There needs to be an I. Sorry, minus I divided by 2. Yeah. Oops. So we're getting 4 lines. So, oh, there's no I divided by 2, sorry. So 7 minus 3 . So probably we don't need it 2 times. So I is initially n divided by 2. So then I is, there has to be a 2 somewhere. Probably here. So 7, 3, 3, 2 times I. Plus so n is 7. I initially is 3. So 7 minus 6. Am I doing something wrong here? 7 minus 6 is 1, right? I is here, right? And it's going downwards. We're printing it here, right? We're printing I spaces, which is correct. This part is correct here, right? Just before the star. And then I'm expecting 7 minus 6, right? I is 3. So 7 minus 6, which is 1 star. Have I saved? Sorry, I had kind of a long day. Okay, I hadn't saved. All right. So, what do we do next? We do the symmetric of that, right? So I'm just going to copy the code. We're going to go from 1, so not from 0 because we can't print the same size of a line. Okay, we have to go to n divided by 2 plus 1. All right, and we're going to print the same thing. Okay. Okay? Everybody agrees? Any other way to do it? So if you look at this line, right? In fact, we don't need these eyes, right? So if you look at this line, right, it can print one line of the of the diamond, but we're doing 2 for loops. So instead of doing that, could you use list comprehensions to generate the sequence of eyes, right? And then do a single for loop. All right, so I can say L is range n divided by 2 minus 1 minus 1 plus range 1 n divided by 2 plus 1, right? And now for I in L, I can do the print. This should be diamond 1, right? Okay. So another thing we can do is to be more economical is to take this and actually put it here. Yeah, take this. And put it here, right? So I don't need L anymore. So then it's even more economical, right? Is this clear? Okay. Yep. Again? No, no good reason. So this is equally good. Okay. And now you probably start appreciating the conciseness of Python, right? So Python can be a reasonably concise language. It can do a lot in one line of code. Okay. Move on to the next one. All right. Diagonal. So it's very much the same principle. Right? So as you move from one line to the next, you have to create a variable distance. Okay? So how do we create this variable distance? All right, so I'm going to do this, the following. I'm going to say I equals 0, and then we're going to do I equals I plus 1 percent 5, let's say, right? So I'm going to evaluate I again. Sorry. And again, and evaluate. And again, and evaluate. Again, and evaluate. And again, what's going to print now? Louder? You sure? 0, right? So we're back here, right? So now it's going to repeat. Right? So it's exactly the same pattern here. First I have 0 spaces, then 1, then 2, then 3, then 4, then 5, then 0. Right? So when I have 5 spaces here, right, if this number is 6, not 5, 6, we're going to have the same pattern, right? Because if it's 5, it goes from 0 to 4. If it's 6, it's going to go from 0 to 4, right? To 5. So 0, 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces, then 0 again, right? So I'm going to use this rolling indentation to create an indent. And then the rest of the line is always the same. Right? I don't care where it ends. So here it ended. Right? Notice that they don't end at the same. It looks like everything is ending here, right? But if I select, you can see that there are spaces at the end of the line, right? And then there are fewer spaces on this line. Sorry, it keeps. Right? So there's this line has 1 extra space compared to the previous line, right? So essentially, if you think in strict terms, if these spaces were minuses, the ending would be jagged, right? So I don't really take care of making it straight. So let's do that. So this was called what? Diagonals. So can we apply the technique that we applied here straight? Right, so I'm going to define a list. Actually, it's not really worth it. All right, so indent equals 0, right? And then for diagonals of just n, can be just n. Columns, lines, gap. Okay. So notice also that the number of columns is, when I say the number of columns, right, the 20 is the number of stars in a row. So 1, if you count them all, right, it's not the actual number of columns. So if we go here, we're in column 124, right? But it's the number of stars in the row that we're considering as columns, right? So for C, in range 0 columns, sorry, for L, so we're going to do the lines first. For L in range, so print spaces times indent, right? So once we've done that, and equals the empty string, once we've done that, we can equals % and we're going to have +1, right? We can already go to the next indent. Then we have to print the columns. So for C in 0, all right, we have to print the star, right? 1 star plus space times yeah. Sorry, this is not columns, this is gap. All right, with end equals nothing. Okay, and this should be it. Yes, I know, I do need a column. That's right. Very good. Thank you. Again? Yeah, that's true. That's true. And again, the wrong. So I have a new computer at work that has a different key mapping. It's getting a bit annoying. We were supposed to write here diagonals. If something like 20, 10, 6, or 5. Right? And I think we have from one row to the next. Oh, that's because I think we have too many columns. So let's say 10 columns. Is it okay now? We're forgetting one thing. So at the end of every line, we need to do a new line. There you go. Indent +1. Nobody caught me on this one. Okay, I'm going to go back and explain in a second. Let's just verify that it works properly. Okay, finally works properly. All right, so remember what I did here, right? I equals I plus 1% 5. So, which means that here I have to write indent equals indent plus 1. I was forgetting this plus 1, right? That's why it didn't work. Again? And the plus 1 after the gap is because again, if this is 5, I'm going to go from 0 to 4, right? So let's go back to the to our sample, this one, right? So here I have, so the gap is 1, 2, 3, 4, 5, right? So now, let's look at the indent cycle. Here I have 1 column, here I have 2 columns, here I have 3 columns, here I have 4 columns, and then I have 5 columns here, right? So because I'm going from 0 to 5, with a gap of 5, right, the rotation has to be 6. The period of the frequency of the repetition has to be 6, right? So when I have 5 here, the period of the repetition has to be 6. Therefore, I have to have gap plus 1. Okay? Okay, assignment 3. Increasing by 1 until you reach the limit and it goes back to 0, right? It recycles. Yes. Okay. All right. For assignment 3, we had learned to use lists, right? So there were many solutions, and there were many good solutions. There are many solutions here. Right? Perhaps the fastest, the easiest is to just have um, the Fibonacci numbers, right? So we want to generate a list. Um, all right. So we start with the empty list. So that's a possibility. And then the first Fibonacci number is 0 or 1, right? And B is always 1, right? So you can start 0, 1, 1, 2, or 1, 1, 2, 3, whichever you like. So now the problem here was that a lot of you forgot that n can be 0 or 1. Okay? So what if n is 0? What should be your result? What should be the result? You could return the empty list, or you could return the list with the 0th number, which you could call it A, right? So it's a matter of convention, right? So the empty list would be fine. The list of one element would be fine. So if n is less than 2, right, we want to return the list of A, B indexed from 0 to right? So we could, for instance, say m, right? So this would be a return. Else, right? For I in range 2 to n, all right? We need to do so if n is 0, if for n we return the empty list, then for 2 we return 2 elements, right? So let's make the convention that we return a list of size equal to n, right? So for 0 we return the empty list, for n equals 1 we return 1 element, for n equals 2 we return 2 elements. So for I in range 2 to n, all right, so if n is 3, I would get 1 element. And actually I would say, sorry, I would say L equals LAB. And then to make things easier to read, I would say L here. All right. And then, what do we do next? So we have A, B equals B, A plus B, right? And then L dot append A, right? Sorry, B. Okay? And then we're going to return L. Does that make sense? What do you mean? So, if n is less than 2. So here we actually have only 3 cases, right? N is 0, n is 1, n is 2. So let's see what happens for each of them. If n is 0, we're going to return the empty set, right? And actually I don't need to write 0 here. Okay, if n is 1, I'm going to return one element out of L, which is just A. All right, which is correct. I have to return the list containing one Fibonacci number. If n is 2, I am going to return the entire list, right? Which is again correct. So first, for n equals 0, 1, 2, I'm returning the correct value, right? For the rest, right, I have to append the next Fibonacci number to the list. So let's say now n is 3. So for I in range 2, 3, so I will only get to B to have the value 2, and it's only one value there, right? What's going to happen? A takes the value of B, B takes the value of A plus B, right? So B now is the third Fibonacci number, and we append it here, and that's what we return, and the result is correct again. Okay? Yes? Colon missing after else. That's true. Right? So let's see. All right, that it works. So do we have 10 of them? Yes, right? And let's check that it works correctly for the small values. So when I have 0, it's the empty list. 1 is the list containing the first Fibonacci number. 2, the list of the first 2 Fibonacci numbers. 3, the list of the first 3 Fibonacci numbers, right? Okay? So it's important to remember that there needs to be some output for this case. This is a corner case, what we call a corner case. You may think it's not important because who wants just the 2 Fibonacci numbers, right? The interesting case is when I want 1,000,000 Fibonacci numbers, fine? But you have to cover the entire domain. Okay? So I'm going to skip sum of positives. So let's do segment sums, right? So many had very convoluted solutions here. So it's a list L and the number K, and I don't remember which is the order. K is first. All right, so how do you obtain a list of length, a sublist of length K? Right? So I'm going to write L. So I'm going to have some start I and some and I plus k, right? And all I need to do is do sum of this, and I have to have this expression iterate for I, right? Right? 0 to right? Yes? And this is what we return. Line 82. Okay, I added a few extra lines so that, oh, there's a missing square bracket here. So this is, there was an example here. Six, 7, 10, 15. Yeah, so there's a plus 1. Okay. Okay. All right. So unique strings. What was here? Just one list. Okay. So let's think a little bit about this, right? If I put this the list inside a set, right? So I want the strings that appear just once, right? So if I put all the elements in a set, right, they will necessarily appear only once, right? Then if I take those elements and remove them from the original list once, right, whatever is left are non-unique elements, right? Yes? Okay, so we can do something like this. For element in set of L, all right? And when I do set of L, this is already a separate set from L. If I change L at this point, set of L has already been put into a temporary storage space, and it's completely separate from L, right? So I can safely remove from L. So I can say L dot remove, I think it was remove, right? Remove, all right? And I can remove E, all right? So is this good? not good because, so let's make L1 equals L dot copy. So I'm going to do L1 dot remove, right? So whatever is left in L1 are elements that are not unique. Okay? So now we can use set difference, right? So I can return the set L minus set L1. Okay? And then what I'm returning is the unique element. Let's use this example. Okay, and we get the result. Now, you may say, oh, but we don't want the set. We want the list. How do I get the list of unique elements? Okay? An alternative solution could be to put to count the elements in a dictionary, right? Use a dictionary to count, and then scan through all the elements of the dictionary and return the ones that have a count of 1. All right, let's try to do the last one since we're coming to the end. So for peaks, how do we do peaks? Again? Can you repeat? I couldn't quite understand. The peaks, right? The last question was peaks. Yes. All right. So how do we do that efficiently? Not exactly sure. So if I want to write it as a list comprehension, right? I can say P, right? For so actually I need to say P of 1, right? For P in, and I'm going to have another list comprehension here, and I'm going to say L, and we're going to have I plus 2, right, for I in range 0 len L minus 1, we're going to minus 1. I have lists of 3 elements, len minus 2, all right. If actually not here. If P0 less than P1 and P1 less than P2, right? So let me add a few lines and let me try to make this a bit more readable. P1 for Pn okay? So P is a list of 3 elements, right? P is a list of 3 elements, right? This P is actually this L from I to I plus 2. Okay? And I don't want all the P's. Only those whose middle element is, and you're going to correct me, shouldn't be this greater, and yes it should. The middle element is greater than the size. Okay? So it is one list comprehension. Yes. Yes. I plus, good point, I plus 3. Good point. So now it doesn't like the indentation. Alright, so one way to continue on the next line is this very ugly thing. You can put a backslash. Okay, here too. So yeah, right? So to explain better what's happening, right? This list is turned into the following list of lists. So 2, 3, 4, then 3, 4, 1, then 4, 1, 2, right? Then 1, 2, 1, right? Then 2, 1, 6, then 1, 6, 5, right? Then 6, 5, 4, then 5, 4, 10, then 4, 10, 9. Right? So that's the thing that we do. We take this big list and we turn it into a list of segments of length 3. And now if I look at each segment, and this is the P, right? This P will in turn be this guy, then this guy, then this guy, and so on, right? So then I can look at each of these triples, and I can decide whether it's a peak, right? So for instance, this one is a peak, then this one is a peak, then this one is a peak, then this one is a peak, right? Cool. Now you had a different solution? Okay. All right. Cool. Okay. So no time for iterators and generators, right? So we talked about iterators so many times. They're a type of objects. We know what objects are. So I would like to show you how to create an object that is an iterator. And then a very special kind of iterators called generators. So we're going to cover that next time in the first half an hour or so. And then maybe we're going to look at it at pandas. Anyway, so whatever we're covering, not going to be covered in any of the assignments. Just for your own edification. Any questions? Yes. I haven't? I thought I did. I definitely have it. Alright, so this is 5 for sure. And alright, that's true. Sorry. I forgot to upload. Okay, done. Sorry for the oversight. Questions? So it's largely about what we did last time. You're gonna be asked, or you're being asked to download files, CSV files, and run some analysis. Okay. Cool.